Once upon a time, not in a fairy tale, but in a boardroom and a college lecture hall, two quiet ideas emerged. They weren't flashy, they didn't make headlines, but they reshaped the digital world and laid the foundation for what we now call the era of information. The first came in 1955, when computer scientist John McCarthy proposed a bold idea: machines that could think. He called it artificial intelligence. The second arrived in 1996, tucked inside a compact business plan authored by George Favallaro and Sean O'Sullivan. A metaphor was born: cloud computing, a way to describe scalable, internet-based services. These weren't just buzzwords. They were seeds, blueprints, the beginning of something much bigger. Today, we stand at the intersection of those ideas. Not just systems of things, but systems that think. In this video, we'll explore the intelligence side of that equation, how artificial intelligence is reshaping digital reasoning, and what it means for the systems we build. In today's digital world, systems do more than store and transmit data. We now expect them to interpret, learn, and act. That shift, from passive processing to active reasoning, is what defines intelligent infrastructure. We expect systems to do what we do: think. Let's start with rule-based AI, the most basic form. It follows predefined instructions. If X, then Y. It's consistent, but it doesn't learn or adapt. As systems grow more complex, we turn to machine learning. These models identify patterns and improve through experience. Instead of being programmed with explicit rules, they learn from examples, just as we learn through practice. For deeper challenges, like analyzing medical images or interpreting messy notes, we use deep learning. Built on neural networks, these models mimic human perception at scale, processing vast amounts of data and recognizing complex patterns. Reinforcement learning adds feedback. The system takes an action, receives a result, and adjusts its behavior accordingly. Over time, it learns to make better decisions through trial and error. Then there's generative AI. These systems create, writing narratives, generating visuals, even suggesting treatment plans. Large language models take this further, enabling rich dialogue and contextual understanding. At the frontier, generative adversarial networks, or GANs, use two neural networks, one to generate, one to critique, pushing each other to improve. It's a digital form of creative tension. Each of these approaches reflects a different facet of cognition: execution, learning, perception, synthesis, and collaboration. And when aligned with strategic goals, they become engines of digital reasoning, supporting decisions and shaping outcomes. There's a compelling TED Talk by futurist Lars Thomsen titled "The Future of AI, Work, and Human Potential." In it, Thomsen suggests that the term artificial intelligence may unintentionally evoke fear, sounding cold, mechanical, and disconnected from human experience. And he makes a powerful point. Could this technology be better understood with more positive terms like ambient intelligence or augmented intelligence? And would that reframe AI as something more human-centered? Rather than a threat, it becomes an extension of thought, a kind of companion that sees the world differently, learns from diverse perspectives, and, like us, occasionally gets things wrong. All part of the natural learning process that every living thing uses. This shift in perspective would change the conversation from automation to augmentation, from replacing human effort to expanding human potential. It aligns with the essence of thinking systems, viewing technology not in isolation, but as part of a broader, evolving human narrative. Because this technology holds up a mirror, this is the first technology that is our first real reflection of us. Evolving into a system of thinks extends the conversation from cloud architecture to include cloud intelligence itself. Leaders who design adaptive, responsive, collaborative, and scalable systems are poised to shape the trajectory of the field. The transition into the era of information was defined by foundational service models, based on virtualized and cloud systems built, managed, and delivered on behalf of customers who subscribe to them, allowing them to grow, share applications, exchange data, and share ideas. As these modular services have progressively integrated, They've enabled sophisticated system capabilities, resulting in the emergence of intelligent infrastructures, systems and applications capable of responding, adapting, evolving, and thinking. The emphasis thus moves from basic tools to collaborative intelligence technology partners, and from traditional infrastructure towards strategic enablers. Ultimately, the central challenge remains: what will you create, and how will it perform?